Well, good morning, everyone. It's 7:02 here in Colorado, and we have people joining. And let me just ensure that this is recorded. How do I find out that this is recorded? It told me it's recorded, but
It
oh
is
yeah, I see.
recording. Yep.
I see a little button on the top left. Yeah, perfect.
Mhm.
Yeah, so good morning, everyone. This is the fourth webinar in the context of the IEA Annex 96 activities around the development and refinement of simulation tools that allow us to explore energy flexibility. And both Zoltan and I would like to cordially welcome everyone to this seminar this morning. We are focusing in this set of webinars on the developments that have been done in the context of CityLearn. And we would like to give the floor to Tiago to make perfect time of the precious minutes we have and allow him to, take the lead from here on. So thank you very much, Tiago, for preparing this and for allowing us to learn from you.
Okay. Uh, Hello, everyone. I'm going to share my screen here. It's the PowerPoint that I have for you. Just let me know you are seeing the wrong screen, I believe.
Correct. Yeah. You have to
So I'm going to change it, I guess.
swap. You have to go to the swap. Yeah, exactly.
Yeah, like this. Okay,
This looks
so
good. Yeah. Mhm.
it looks good for you?
Perfect.
Okay, thank you, everyone. Good morning for you. It's very early in there. For us, it's 2 p.m. So good afternoon for the people that are in Europe, and for everyone. Yeah, thank you for the opportunity to present the work that we have been doing on CityLearn. We discovered it by chance in my master's degree. I opened an issue on the GitHub, and since then I've communicated with Zoltan and with other people from there, and they have been fantastic with us to let us develop some things into here and to let us bring innovation into CityLearn. So that's what I'm going to present to you today. I'm Tiago, and here also in the meeting is my supervisor of my PhD thesis, which is Professor Luís Miguel Moreira Lino Ferreira. So welcome everyone, and I'm going to start. So as a quick presentation, I'm in the second year of my doctoral program. I've been working since my master's degree on AI and reinforcement learning optimization for local grids, energy communities, district level optimization, and something like that. And I needed a tool to simulate all of this, okay? And I came across with CityLearn. So today I'm going to talk with you a little about the context and motivation that led us to our work and to finding CityLearn, the requirements that we had to do some of the modifications, the modifications to CityLearn, and some results that we have by using it, and some outlines for future work and some conclusions. So the context and motivation, I start with an AI generated image because why not? Today it's all AI, so I started with his. And this is mainly our context. We are shifting from houses that do not have production, decentralized production. They do not have PVs. The cars are not electric, and we are shifting into houses that are mainly with decentralized production. We have more EVs in the grid. So this is our, let's say, shift in energy consumption. This is driven by a lot of public perception, green deals, government incentives here in Europe and in other places. But here in Europe, we are a little focused on that. Um, by energy independence of the homeowners, and also by cost reductions, which is also an important part. And we have the technology that permits it, which is IoT, artificial intelligence, among others. This increased the electric vehicle adoption, the renewable energy generation, and the distributed energy generation, and the creation of a thing that we here in Europe call renewable energy communities. um, when I found about CityLearn, you call the thing that you simulate district level something like you simulate a district. Here in Europe, we simulate, and we have a way to tell something similar, which is renewable energy community. A renewable energy community for us, it's a group of houses. Here in Portugal, they cannot be further away from each other more than 2 kilometers. But they are a group of houses near each other that can exchange energy between them and optimize between them. Okay. And so the motivation that we have from here is the application of these technologies into the real world, and we have an European project that is funding this investigation. I bring here the project because the project is on the optimization of electric vehicle autonomy. And when we started it 3 years ago, I was looking for simulation that let me simulate the district and also the electric vehicles within the district, within the renewable energy community, because our main objective was about electric vehicles. So you already know this, the curve, but I'm going just to tell you something about it, because the peak in the late afternoon, when we add EVs into the grid, there are studies that say that peak in the late afternoon can increase up to 30%, because it's when the people get home, connect their EVs, and it's bad for the grid, and it's something that we need to optimize to distribute the load evenly throughout the other hours. And how do we distribute this load? That's what I'm going to show you. But first, we have inside this project two real world, let's say, places, two real world demonstrators. Okay, we have a company that's iCharging that sells chargers to all of the world, and they have a car park inside their office with 18 AC chargers. Okay, all of them connected at the same time. They consume hourly what is basically around 25 Portuguese households would consume in a day. So this is a lot of consumption in this building alone, and they do not have the power to power it all on max. So this is an object of optimization, and it's also one of the things that we would like to simulate in CityLearn when we started. So we have this building, we have 18 chargers inside the building. Each of the chargers have a max throughput, which is 11 kilowatt an hour for this case. Okay, and this is one of the situations that got us into the simulation. The
Did you
other,
say,
yeah,
Tiago,
sorry.
it, on the previous slide, you said 11 kilowatt hours, but you mean 11 kilowatts, or which one do you mean?
Yeah, 11 kilowatt. Yeah, you are sure. The
Ah,
hour there, it's not
okay, it's okay.
correct. Yeah, it's 11 kilowatt. And thank you for correcting me in there. And then we have CleanWatt, which is another company that we are working on this project, and they have renewable energy communities. And renewable energy communities, it's what I said before. They have a lot of houses spread in a near place, and these houses can be from dozens to hundreds. Okay, and this is what you already have in the CityLearn, but these houses can also have EVs and chargers in there. Also, another thing that CleanWatts also wanted and led us to some things that we developed into CityLearn was that each house could have their own objective of optimization. Okay, so one house could want to reduce their costs, the other could might want to reduce their CO2, and the other might want to increase their renewable energy. And besides this prosumer or this house objectives, we have community objectives, which are the objectives for the optimization around all of the community, which could be, for example, reduce the peak consumption. And with all of this, we have the demand response, energy flexibility management, and energy storage solutions to resolve some of these problems. And you have in CityLearn all of this before we came in. And I tried to input into CityLearn two other strategies, which is V1G, which is smart charging. Basically, it's choosing the right period to which we will charge the car. For example, you tell us, I'm going to leave at 8 a.m. Tomorrow, and I'm going to need 80% charge. So I know that from now until then, I have the flexibility to charge to meet your requirements. The vehicle to grid, it's the same for charging, but it allows also for the cars to discharge back into the grid. This is not a real, let's say, a real thing that happens in the world. Not much cars have vehicle to grid, and not much chargers have this possibility. But since we are developing for investigation, it was also one of our requirements that the simulation that we were programming would allow us to do this. Okay.
Iago, you're arguing that neither V1G nor V2G are commonplace.
No, I'm arguing that the V2G is not common. V1G, it's more common, and it's possible with the technologies that we have, the hardware technologies that we have. The vehicle to grid, the V2G, it's not so much implemented. Most of the cars in the market don't allow to discharge the battery into the grid. And also the chargers. For example, from our partners, iCharging, and most of our partners in the project and the things that we have been dealing with, they do not allow this capacity for the car to give back to the grid. Okay, the V1G, it's more common. It's just charging the car whenever we want, at the hours that we want. Okay.
And at the rate we want. And at the
At
rate
the
we
rate
want.
we want, yes, and at the rate we want. The thing about the rate, some chargers do not allow that. The more dumb ones, they do not allow for you to control. They just allow you to on or off. But the more intelligent chargers, which is a bigger reality than the bidirectional chargers that are needed to vehicle to grid. So the intelligent chargers for smart charging are a thing that has been placed in the market a little bit more. But all of this is more on investigation, and as you are going to see later in this PowerPoint, we are trying to put our algorithms into the real world, into that demonstrators that I told you about earlier, and it's not that easy. So one thing that I tried to do when implementing this into CityLearn was to be able to simulate different things. And for example, you have only a charger that only turns on and off. Okay, that could be simulated. Oh, now you have a charger that can only charge between some amount of values. That can be simulated. Now you have a charger that can also discharge, and that can be simulated. So you can simulate different things upon your case or your demonstrator needed. So the requirements, it's mostly what I've been telling you about. When we found out about CityLearn, it didn't. It was lacking the support for EVs and chargers. When I talked with Zoltan, they told me it was a thing that they were thinking about, and I I, I said, okay, but we are also thinking about that, and then I said I'm going to implement it, and we agreed on some, uh, let's say, design on how to do it, and for me to introduce it into CityLearn. So the requirements and that we had was to have several available prosumer objectives. This is one of the things that I told you, mainly because of our demonstrators. Several community objectives also for our use cases. We needed to be configurable for different scenarios. That was the thing that I was talking you about. If we have simple chargers, more intelligent chargers, vehicle to grid chargers, what I wanted was that all of them could be configurable in the simulations for all of these things to be tested out. Okay, and some of other stuffs that I'm going to tell you in a moment. One of the other things was to be compatible with previous versions. This was needed because people can still use CityLearn without the EVs, and easy to maintain. This is mostly on design of the code itself. So the modifications that we did. First, I'm going to tell you about EVs and chargers, okay? Then I'm going to tell you about a thing that we also introduced, which is about the breakers that could be in an installation and their capacity. We also introduced washing machines, some stochasticity to the values, and we also dealt with the time step granularity, the render. We have done an UI that I'm going also to show you, and some tests that are now integrated into the version 2.5 of CityLearn. So I'm going to start with this. Our main goal when we started this was to add EVs, the battery of EVs, their behavior, their chargers, and the flexibility. So the flexibility is what I said to you is I'm going to leave at 8 in the morning and I need some percent of charge. That is our flexibility. Okay. So we added electric vehicles as a thing that belongs into the greater CityLearn environment, okay? And chargers as a thing that is an electric device, which is a device and which is inside a building. So a charger, it's inside a building, and we can have one or more chargers inside a building. Each electric vehicle can be connected into a charger when it's plugged in, let's say. The electric vehicles can also exist in the environment, not connected to any charger. The electric vehicles use a battery that was previously designed for a home battery, but we did some changes, and they use a battery for their simulation on the battery itself. Okay. So this was mostly the design. The integration with CityLearn was via a config file in the schema, as you may know for all of the other things. And the profiles of the charging and the flexibility are from a CSV that I'm going to show you.
Just a quick question.
Yeah.
The battery you show on the bottom there, is that the EV's battery, or is this a home battery, or is this either or?
It's neither or. This is a class in software. It can be instantiated as a home battery, but this is not the case for electric vehicles. For electric vehicles, I I used some of the methods like charge, discharge, and the things that are common for a battery all over. Okay.
Mhm.
So the electric vehicle owns a battery. It's not a home battery. It owns its own battery. Okay. Um,
But you could
it's
have
just
both.
we can have both also. Yeah,
Okay,
we can
that's
have a
all
home battery and the electric vehicles with their own battery. Okay,
perfect.
it's not a problem, and we can have as many electric vehicles in the environment as you want. Okay.
Mhm.
This is, I think, it's going to be a little more explaining here. So if you go to this data set, that's one we took the CityLearn Challenge 2022, and we added EV's data into it. Regarding the actions, you just go into the schema and you have this thing here, which is electric vehicle storage, and you activate it as true because this is the action that's going to be applied to the charger. Okay, and the charger will charge an EV. The way we did this was that um, this action that the controller decides, it's between a lot of things. So first, let's say we have it restricted by the minimum and maximum charging amounts of the charger. Let's say the charger can do 1.6 kilowatts to 11 kilowatts. Okay, so our minimum is 1.6 and our maximum is 11. And then this action is passed into the charger. The charger can have its own efficiency. So the energy is calculated, and then we have the resulting energy going into the EV. This energy that goes into the EV also suffers from the maximum and minimum amount that the battery can receive and from its efficiency. Okay, so this is all calculated. This is explained in the CityLearn version 2 with more equations and more mathematics to explain all of this. The observations that we have for the electric vehicles, this is also in the schema, are the connected state. So if a vehicle is connected or not to a given charger, notice that the observations are always from the charger perspective and not from the electric vehicle. Okay, so what I'm telling you about is we are in a building, let's say building one, and we are receiving observations for that building that we have a connected car. Is it true or not? We have a connected car or not? If it's connected, we are going to know which car it is because it's connected to our building. If it's not connected, we are not going to know what car is. So this goes into the rest of the observations. If a car is connected, we know that the connected electric vehicle at charger, we know its battery capacity and receive it as an observation that we may want or not to pass into our controller. And then we know about the connected electric vehicle departure time, which is I want to depart at 8 a.m. And the connected electric vehicle required SOC at departure. SOC is state of charge. So we know that the person might want to leave at 8 a.m. with 80% charge. Okay. We also know its state of charge at the moment here, which is another observation. And we added two more things. These two things that you are seeing here are to simulate the following. For example, this is the electric vehicle charger incoming state. Incoming state is to tell, it's an observation that we can tell the controller that the vehicle is coming into our charger. And we also have the observation that says it's expected to arrive at some time. So let's say we are in the future and you want to simulate some future stuff that is you put into your GPS, Google Maps or wherever, that you are going home. And your home automatically receives that information and knows that you are coming in 2 hours, let's say. So the controller is expecting you at in 2 hours. Okay. If you do not want to use this, you just put it to false, and you can do the simulation with only the things that are above. Okay. In the schema, you define the electric vehicles like this. There is a section that is electric vehicles definition, and inside that you give the names for the electric vehicles. You put their battery, and you specify these attributes. These attributes are the capacity of the battery in kilowatts hour here, the nominal power, the initial SOC from 0 to 1, this is 25%, let's say, and the depth of discharge of the battery that you want to go. So basically, this tells the environment that the battery cannot go below 15%.
What's the
Here
nominal power? Tiago, nominal power is 50
in
kilowatts.
kilowatts, yeah. Here in this case, yeah. Capacity is kilowatts an hour, nominal power is kilowatts, and this is percentage of the battery. The chargers, we also have their definition is inside the building, okay? And inside the building, you can specify a section which is chargers. Inside chargers, you can have charger, let's say 15.1 or 15.2. This nomenclature is about 15 is the house, 1 is charger number 1 and charger number 2, but you can give whatever you want in here. It's just a name. And then you point towards the file that has the information about that charger, and you have, for example, the attributes, the nominal power here in kilowatts, the efficiency of the charger type 1 here, because chargers can be AC or DC. Okay. This doesn't do much in the simulation, but it's a thing that we already put in the schema for probably some future modifications. And then you can specify.
Everything's on a real power basis. Is that right? You're not modeling currents.
We are not modeling currents. No, we are modeling power because
Real power, yeah. Mhm.
real power. Yeah, because it was the way that when we encountered CityLearn, all of the other assets were mainly simulated. Okay, we deal with power and energy, not the other
So,
things.
okay. The EV that you define on the left side,
Yeah.
this is an EV that is uh, associated with a home, or could you also have guests stopping by, or is this just not of interest, right? You mostly have homeowners having their own EVs, correct?
Yeah, mostly is about homeowners having their EVs. If you want to have a guest, uh, you can have it, but in the simulation it needs to be defined. Okay. Here,
Okay.
as I'm going to show you in a moment. Here, as you see, it's not associated with any house. This is just an EV that exists. Okay. And the charger also does not associate with any electric vehicle. I'm going to show you next how this association is done. Just to finalize this, you have the max charging power and the min charging power. And if you want to discharge in that vehicle to grid thing, you can define the discharging and powers that you want. If you put both to 0, it does not discharge. Okay. Um, so the data set that is from the electric vehicle, and this is here where we do the association. I'm going to tell you about that. We have in the data set that you see associated with the charger. Okay. We have first a number that tells us the state of the electric vehicle. For it can be parked, it can be incoming, or it can be commuting. This is from the perspective of the charger. So let's say I'm in the building, I'm looking at my charger, and I have a car parked here. So 1, I have a car incoming for that strategy that I told you about, or I don't have a car here. Basically, it's commuting, or from our perspective, we do not have anything here, and we do not have anything incoming. And then here we have the vehicle ID, which is the identifier for the electric vehicle. And it's here that we do the association. So it's the charger that knows which vehicle associates with him. Okay. So yeah, in a normal homeowner thing, you can have its own vehicle coming to the charger every day. But if you want to have some visitors, you just need to define an electric vehicle that stays in the environment, okay? And then that electric vehicle, it's identified in this file and it connects to wherever charger you want. And then we have the departure time, which is whenever the vehicle wants to depart, the required socket departure normalized to 0 to 1. And the other two things, which are the estimated arrival time and the estimated socket arrival. Okay, this is the things that I told you about in the observations. They are basically the same. And I'm going to step out of here just a moment
So
to
the
show.
departure time, Tiago, is
Yeah,
not a clock time, but it is time steps away from now. Is that
yeah.
right? Why
Uh,
not a clock? Why not a clock time? Why not an actual schedule?
because this was one of the things that we thought. Okay, we do not have in reinforcement learning defining a time. It's difficult because if you can see here the data set, let me just get into here into, for example, building one. You just define the month, the hour, and the day type. So for example, let's say you
By the way, you're
define.
not sharing that. We're seeing a
Oh,
colorful lion.
okay, let me share this better.
Yeah, we see that.
Okay. um you just define the month, the hour, and the day type. For example, if you say that the vehicle is going to leave tomorrow at 8, you could put 8 time 8. But for the controller, it would be very difficult to know what is this 8, because reinforcement learning doesn't really know what this 8 means. So I tested with both things, okay?
Mhm.
And the results were better when I told the controller that the time it's like 12 hours, 11 hours. Or it's not hours for it. It's just 12,
Yes.
11, 10. It's closing out on the target, okay? Um, defining a
I just
number was not
I just
getting
had a hard
into.
time understanding how departure in time steps can be a characteristic of an EV. I thought that's more a current state, and that changes every time step, right?
Yeah,
Because
that changes every time step. I'm going to show you here.
oh God.
Uh, let me just check here. This is the arrival. Yeah, for example, here. This is a data set of an EV, okay? And you
Mhm.
have the charger. This is the data set of a charger because we are seeing from the perspective of a charger. And we have the charger state. So we have a connected EV. Our connected EV, it's vehicle 7. And the departure time is in 12 time steps or 12 hours. Okay.
Mhm.
And this is decreasing until the moment it departs. And we have the socket departure that is needed. And we do not have arrival time nor estimated arrival because it's connected. Okay. And then, as you can see, the vehicle, it's connected. Uh, it's doing wherever the controller wants until here. It just needs to, we can put the controller to target this sock at this hour, not this hour, but until it runs out. And then the vehicle is away here. We do not have anything in here. And then we have here a case which is the vehicle commuting. We know that in some time electric vehicle 7 is connecting into our charger, and it's going to arrive with an estimated SOC of 76%. Okay, And then, okay, it connected. There's these time steps for it to go out, and it needs to leave with 88%. And this repeats itself all over, okay? And one of the questions that we get much is, how do we get this? Okay, how do we get this flexibility? And this is really a problem that we have at the moment, because you have two options. You can put the person to connect within the system through an app, let's say, and the person says, I want to leave every day at 8 a.m. with X% charge. That is awesome. We have that. But for example, if a person is more not so I don't know the word, but not so
Regular in the
regular,
behavior.
yeah, not so regular. You might want to change this every day. So the person needs to go to the system and change it every day. In the work that we have been doing, we have some kind of predictor to when the person wants to go out and what amount of charge. Okay. But this design into CityLearn allows everyone to put it here as they want. Okay. This is your data. You say that the person always leaves at X amount of time. So you define it like this data set here, and you can simulate however you want. Yeah, I'm just going to continue, and it's again swap. Yeah, better.
Is this, Tiago, good time? I know
Yeah,
you have 20 more minutes. Do you want to see if there are audience questions on that? Because I think that is the main configuration, right?
yeah. If you have any questions, tell me. Please interrupt me and go ahead. Okay, maybe I will.
Other than Professor
I will
Hansen.
ask a question, Tiago. Maybe you mentioned it, but I snoozed out. So, following up to what Gregor said, if in the house, if you had a battery for the house, but also an electric battery in the car, can you like charge one from the other, or is it all just kind of like one? Okay, so you could technically charge your battery from the car or the grid. Okay. Okay,
Yeah,
cool.
they are completely separated. Okay, this let me
Okay.
show you the here. You have the electric vehicle definition that I was telling you about, and then we get into the buildings. Okay, each building has a name. It has whatever it all had before, which is electric storage here, which is the battery that it had before. And then it has washing machines, which is the thing that I'm going to show you next. In a moment, it has PVs, and it has also chargers. The charger, it's a thing by itself. It's completely different. There are different objects. The socks are different. You can have whatever of this. Okay.
Cool. And there was a question in the chat. How many EV is it? Is a number of EVs per charger limited, or you can have any EVs to the charger, right? It's not
At any
limited.
given time step, you can only have one connected. Okay.
Right,
That's
right. But
that is
you don't
the
have to fix the relationship. You can have 10 cars, but at any given time it's just one.
yeah.
Yep.
Yeah, at any given time, you just connect. You can have one connected because that's the real world stuff.
Correct. Yeah.
But in our simulations, we tested out with. I'm going to show you next, but I believe 18 cars at the moment, and very EVs, and it went fine. But I'm going to show you. I'm just going to go over the PowerPoint a little bit faster because we are running out of time. Let's just change this a little bit then here. So another thing that I've done, and maybe it's not interesting for you, but it's a thing that we needed, was constraints, because buildings usually have limiting power to them. Okay, so this is also in the schema. We can define the limiting power of the building, and we can define that it has, for example, here in Portugal, I don't know how it is in there, but I think it's the same. We have one phase or three phases. Okay, it depends on the installation. And here you can define phase one, phase B, or phase C, whatever. And inside each phase, you can tell a limit to that phase. Okay. in our use case of that company, which is iCharging, which has 18 chargers, they have different chargers within each phase. Okay, so this is our form of modeling that. We can say charger 15.1, it's in phase 1, phase A, and charger 15.2 is in phase B. And this is then treated however you want. You can treat this in the rewards, or you can treat this as an hard definition. We treat it as a hard definition, but it's something that it can also consume. We also added washing machines. I'm not going over a lot of this, but washing machines for us was another project. And washing machines have some flexibility. You can say, wash it during the day, and it washes wherever it's more suitable, whenever you have more solar, whenever you have more power for that. So basically, the implementation, it's the same as the other all assets in here. It's just another class. You have a washing machine, you have a CSV that defines its power needed and the flexibility. Okay, you have the observations here. It's basically the same. It was taught.
It's a delay on washing machines. You mostly delay the
Yeah,
cycle, right?
mostly delay. You have a cycle that needs to be met, which is here. Let me just here, for example, this washing cycle was only 1 hour. So basically, what this dataset tells us is it can have 3 hours to do a cycle, which will consume this in 1 hour. But if you have more hours, you can define in this list the amount it takes at each hour, so the cycle, let's say, and it can start whenever around this cycle. Okay, basically it's delaying the start, but the cycle we cannot stop it at the middle. The cycle, once it starts, it needs to go. We added some stochasticity. Basically, this was for us because we have been collecting real world data, and real world data, it's real world data, but to train the models, we need to change a little bit. So we need to add some noise to it. So there's a trigger. Okay, let me just check. You can trigger some stochasticity inside of some assets. Basically, it's just done into electric vehicles at the moment, but it's an idea that we have, and it's already kind of in the code, and it's configurable as this. This is badly written here. I saw this now, but in the code it's okay. I changed this just for the presentation yesterday. So yeah, you can add the amount of stochasticity you want. And then we have the time step granularity.
And what does 0.8 mean? What does 0.1 mean? Is
0.1 means we have less variation, and 0.8 we have more variation. It's easier
but
to
you
say
have different
like this.
noise models. We have different
Yeah,
noise
we
models.
have these ones here. We are using Gaussian noise because it's the faster one. Because we can also do some historical perturbations because of the getting data and resampling it, but it's more compute intensive. Okay, and we can also do scenario-based simulation, but at the moment we are using Gaussian noise, and when you define that, you define how much it injects into there. Okay,
I would suggest adding a Gaussian noise is fine, but I would suggest adding the temporal correlation because if it's uncorrelated, it just does not quite reflect reality.
Yeah, this is just a thing that we thought, and in the end of the presentation, I have a lot of ideas for what CityLearn can be, and I think this can be also a thing that can be there, and as you said, better implemented than it's at the moment. Okay. Yeah, just to go over also time step granularity. When we got into CityLearn, there was this property defined, which was seconds per time step, but it wasn't doing nothing, basically. So we put it into work. So you now can define simulations that are 1 minute, 15 minutes, or whatever you want. We calculate a ratio, and we do the computation to know how much energy goes depending on this ratio. Okay, so now it's basically aligned. You can have simulations within minutes. You just need to add this column into the data sets, and you need to define how much seconds are per time step at the moment. Okay. This is the one of the things that I wanted to show you because it shows a lot. We implemented the render and an export. Okay. We tried to do it in JSON. JSON takes a lot of time. So we chose CSVs to export all of the things that we do in a simulation. This takes more time than not rendering it. Okay, but if you really want to render, this is the best option that we have at the moment. So we export what is in a simulation, and it's exported for the CityLearn UI that I left this empty to show you. So we had one guy, which was Jose, implementing the CityLearn UI. Okay, and the CityLearn UI, it was a thing for us in the beginning, but it's a thing that is published in this thing here, and you can find all of the documentation that you need in the CityLearn documentation. It's all described how you export the data, the code for it. You have two modes to export. You have the per step export, so you export into a file every time step. This is more, let's say in the future, you want to see your simulation running as it is running, or you can export at the end just to check the results after the simulation has completed. Okay, this is all explained, how you select simulations, how you view them, how you can see the KPIs, but I'm going to show you because it's more interactive. So I have uploaded simulations into here, okay, and they are here, all of them. They come here in the format that you simulated them. So we have building 1, building 2, and wherever you might have in the simulation. At the moment, we only permit or show electric vehicles. We do not show, for example, heat pumps. We show batteries, but not heat pumps. But it's a thing that we have another master student probably doing this year. Okay. So for example, you can see the pricing. Here you click here and you can see the pricing for this simulation. Basically, you can see at each time step whatever you have in the data set, and you can show more or less whenever you want. Okay. Then you have the EVs in the simulation. For example, electric vehicle 1, you can see its state of charge here, and then it decreases. This is going to be more it's going to be better when you see the charger because it's aligned with that. Electric vehicle 2, 3, 4, whatever. And then
Cool.
we have the buildings. Building 15, it's the one that has 2 chargers. Okay, so we have 2 chargers here. All of the others, for example, building 1 has 1 charger, and building 3 doesn't have any charger in here.
Perfect.
I'm going to
It's amazing.
Yeah, I'm going to go into building 15, which is production. Production doesn't have a lot, but consumption it has here, and you can see from non-shiftable load and the net electricity consumption from it. Okay, this is the 2 values that we got from the environment. Probably we can get more in the future. And then we can say charger 1. Okay, let's see into charger 1. This is the most complicated view of them, but here in orange, you can see the departure sock that the person wants. Okay, that thing of the flexibility. And in red, when the person goes away. In blue, when it's arriving, when it's getting into the charger. And all of the other, in the black, it's the state of charge of the vehicle at that given moment. And here, you can have the consumption or production. It depends on the color, but here it's consuming energy into getting into 100%. This is not a reinforcement learning. This is just an RBC to show you. But the RBC charges at some hours and discharges at another. But here it charges and then discharges and then charges again, and the battery changes. For example, here you can see that the battery, it's incoming for 3 time steps, okay? And the estimated socket arrival is, let me get this out of the way, it's 9%. So the vehicle, let's say, this is randomized. The SOC, when the vehicle is not connected, is randomized. But we know that it's estimated to arrive at 9%. So it arrives with 9% at the charger, and then the charger gets into it until it departs. Okay. Just going to show you some. This is the batteries simulation. The state of charge goes up and down because it's just the RBC. This happens for all of the buildings.
These are the EV batteries, right?
No, these are building batteries.
Home batteries. Okay.
This is the building battery. The EV battery, you need to go into the EV and check, for example, its battery here. Okay.
Thank you.
And then I'm going to show you just this one, which is a quick simulation that I did, just to show. This is just little time steps, but as you can see here, the interval in minutes is 15 minutes. So you have midnight, 15 minutes, 15 past midnight, 13 past midnight. So we can also see this as this, okay? And just another thing, this is another simulation, which is similar to the other one, but we can reduce these things or just to see more or less of the things that we want to see in here, okay? Then just let me
that
go
UI
over.
is amazing. That UI is really helpful.
Yeah, it's really helpful for us.
I agree.
That's
it's
why
very
we
nice.
did it.
Yeah.
And it has some bugs, as you are seeing here. But for example, you can select all of the simulations and it shows you the KPIs, okay, for the district and all of the buildings that you have. And for example, let me just check 2 that are comparable, these 2. So I'm going to compare this one, the one that I'm selecting with that one. So what it's going to do is to have a new tab here that says comparison. And if the values change, it highlights them in green if they are better, in red if they are worse, comparison between this one and the other one, okay? And just another thing that I know
really
we are
sweet.
getting out of time is that we created this thing here. You can create a schema from here. You can give a name, tests, for example. You can put the random seed. All of these things here are the ones that you have in the schema, but you can select observations from this list. Let's say you have month, day type, hour, net electricity consumption, and electricity price, okay? And you can select the actions, that is electrical storage and electric vehicle storage, okay? You can select a lot of other stuff that are in the schema. You can tell the schema name, it's going to be schema. And here it's the good part. Let's say you can drop a building here and you can say you have a charger. Oh, I hope this is working. Oh, it's going here, sorry. And you can say here it has 2 chargers and you connect the building 1 to these 2 chargers. Okay, you can change the name of them. You can put the type, the efficiency, the type, the max charging power, discharging. Also for the building, you can say observations that are or not in the building. So you can configure all of the schema from here.
It's a configuration tool for CityLearn.
Yeah, basically an UI for doing that. Because we wanted our students that work with us to, most of the times we have, let's say, informatics students that know how to go into the code. But sometimes we have students that do not know how to go into the code. But we want them to go and to do simulations, which is important for us. And we needed a way for them to interact with the system in this way, as you are seeing, because it's more interactive. You can also define, for example, PVs. Let's say here you have a PV, and let me try to save, and I'm going to open it. Yeah, block notice. It's it's not the best, but you are going to see it like this, and it defines the schema in the format that we want. Okay.
It's really useful for beginning modeler in CityLearn, right?
Yeah, that's the idea. You can have the buildings. You can see here building 1, okay, and it has charger, the name that I put it, and the other charger is here. Okay, so it's like this. It's not perfect because it's the first iteration of the UI, but it is a thing that we are investing a little bit of time and a little bit of effort, because I think it's very important for us. This part here of the simulations is very important because we can see the what is happening in the buildings and correct whatever it's needed for the chargers, see if they are working or not.
So for the post hoc analysis, this already works very well. But you know, Tiago, we have an upcoming common exercise, kind of a competition in the beginning of the new year, and I can see a number of teams deciding to use CityLearn UI if that is available. Is there a reason against that?
No reason against that. We just probably need to refine. I know some things that are not perfect. For example, here, as you can see, this is not formatted. And another thing, it's when you reload, sometimes it goes out. Basically, there are some bugs that we are aware of, but we have been working to resolve them. And
Tiago, I think that's okay. I don't think we don't imply that it has to be perfect for it to be useful. It's more that I think, correct me if I'm wrong, Gregor, but the question was more whether or not people can already use it, and then they can tell you if there are bugs. I mean, that's quick. But it was more about, is it available? Is it in the latest update, and people can download and use it when they pull? Excellent.
Yeah.
That was the main question, and then there is information there to use it.
The thing that we agreed is that we have a free hosted version in here, which is the thing that I'm using. Okay. But if you have sensitive data and you do not want to load your data into there, you can go to our GitHub, and in our GitHub we have the code for it. So you can download it and put it to work whatever you want.
So people can use it already, and it's not a problem. Okay, very good. I think that was a question in the chat, so that answered that. Really cool.
Yeah, at the moment it only supports EVs and batteries. It's a thing that we are going to support more things in the future, I hope. And it has some bugs. We know them, but we are working on that. So yeah, just to finalize
it's a never-ending work in progress, that we understand.
It's a never-ending work in progress. Yeah, just to finalize this, because I'm getting completely out of time. I added CI/CD into CityLearn, so whenever now a thing goes into master, it has tests. So 86 tests at the moment for them to check if everything is correct, because it was a difficulty that I was having when pushing code. Okay. And then just to show you, I'm going to pass all of this, but just to show you our case, we have 17 buildings, which are residential. We have the office and the factory that I showed you from our partner companies. And we have a number of cars in the simulation, okay, that are associated with one or more, depending on the files. And so we have results with that. The thing is working fine. And we have different cases that we studied. For example, no control, then putting an RBC, then putting reinforcement learning, and then putting more batteries.
In the presentation mode, it's a little small for me.
Oh, sorry. Yeah, what I was saying is that we did a lot of tests with this thing. For this configuration, okay, that we have for our project, we extracted the results without control, compared to our baseline, which was not being in the community. It's our baseline. Whenever they are in the community, they get a 20% discount off of price. So and they can exchange energy with their neighbors. And then we put an RBC, and then we put reinforcement learning, and then we tried some more things, which are putting batteries in homes that do not have them, and try to work out a financing model that can give these homes a battery so everyone gains in the community, and having more PV. So we tested out with different cases. Okay. The only thing that we do not dealt with was heat pumps. Catherine, I'm sorry if you are there, but it's a thing that we, in the future, probably we are going to deal with because we need them. And future work, I'm just going to say we have this implemented. It's not on version 2.5 because it has a little bug, which is building specific objectives, which is a thing that we use for our system. Basically, for building 1, you can specify that my reward is this, and for building 2, you can specify my reward is that. So it's different objectives for different buildings. This is not on the published version, but it's a thing that is implemented, and we are refining some stuff in there. And then other improvements that came to my head are reduce the loop time, because it's the most important part of this simulation is to go fast to train the reinforcement learning. I have a colleague it's also here in the meeting, which is Pedro. It's working now on CityLearn to try to improve these two things, the reduce the loop time and improve the code structure, because it's all in the same files. And for us, it's complicated to work all in the same file. For example, CityLearn file has, I don't know, 3,000, 4,000 lines. And from a perspective of maintainability of the code, it's better that some functions, for example, the load, can go into another file, which is easier to deal with and to test. Okay. Then we can have, as an improvement, different prices for grid consumption and district level consumption. For example, if you want to do a discount for inner community consumption, you can have different prices. We need to improve the export functionality, because to add other devices, like for example the heat pumps, improve the UI for an easier experience, because it has some bugs, as I said. And another thing that we are thinking, this is way in the future, but it's a thing that we are thinking, it's put it into here, because we simulate with CityLearn a community. What if we can have 2, 3, 4 CityLearns working on parallel to simulate 3 or 4 communities, and all of them communicate with an operator, let's say an aggregator, that can distribute or get flexibility from one community into the other. But this is just an idea, just a future idea to present here. Okay, and then I think it's all. I need to thank all of the funding and all of the companies that are with us, and that's it. And I don't know if you have any doubts.
Fantastic. So, Tiago, this was a fantastic seminar. Thank you so much for all the preparation and time. I think I slowed you down with a few questions that I had.
No
I hope
worries.
the questions were useful. For the rest, this is again recorded. Just last question for me to summarize. Currently, your CityLearn does not allow for building thermal dynamics and heat pump control. It is looking at the EV side only. Is that a fair assessment?
No, it allows, okay, because my CityLearn is inside the CityLearn.
Mm-hmm.
So the person can go there and implement heat pumps and thermodynamics, and it can also do that with EVs. We only focused on EVs.
You only for okay. Now I understand.
We only focused on
Diego, right,
there was a
the
limitation.
the UI doesn't show you heat pumps and stuff, right? So
the UI
that's something
allows you
made.
to create the schema for heat pumps. That part there. But it's a thing that I talk with Catherine, and probably are going to meet this week or next week. For
She just
her
raised
to
her
tell
hand
me,
also.
for her to tell me what we can do and how we can incorporate heat pumps into the UI. Yeah, Catherine, you raised your hand.
Hi, everyone. Yeah, sorry. I hope we have time. I just have a quick question. I actually had two questions, but cut me off if we don't have time. My first one was about the EVs. So one thing we talked about, I know a long time ago, was the idea of like if you have EV1 associated with building one, let's say like their own home, and then you have building 10, which is let's say some kind of MERB, like multi-unit, but they have like a high-speed charger, for example. Can this new version handle the EV, like let's say traveling between buildings?
Yeah.
Okay.
At first we had simulation from the perspective of the vehicle, and that did not allow us to do that. Since now we have the simulation from the perspective of the charger, we can have the vehicles exist in the environment, and we see them connect into each charger. We can have them connect into the charger of their own home, and then in the other file of the other charger, they can connect at the midday because they traveled.
Okay, perfect. That was my first question. And then my second question, at the end, I heard you very briefly talk about, let's say, building 3 has excess PV and they want to then take that and then they're able to like charge a battery in building 2, like building to building resources, because previous versions of CityLearn I know weren't able to handle that. Is that something you also incorporate?
They do not allow. It's just accountability
Yeah.
thing. But from our side, we did that accountability. Let's say if building 3 has access, we assume that that energy goes into the building 2 that is consuming at that hour. Because we in the grid, you cannot deliver from building 3 to building 2 directly. Basically, what you have is export of building 3 and import of building 2. The accountability that you do for that is that here in Portugal, at least it's this. If building 3 exported 2 kilowatts and it's inside the renewable energy community, we know that that 2 kilowatts are going to go to whatever member is consuming at that time in the community. Okay, this is our grid does that accounting, or should do, because we are a little late on that, but it's the design.
Okay, so your assumption with this newer model is that if you specify your community that you are able to do that, let's say sharing within the community itself, if there's excess somewhere.
Yeah.
Okay, very cool. Thank you so much.
Thank you, Catherine.
Yeah.
Good. Well, I think we are just a mere 10 minutes beyond time, so that's not all that bad. Tiago, I think if there are no further questions at this point from the audience, then Zoltan and I would like to again express our gratitude for preparing such an excellent webinar today, and we're happy that this is recorded for posterity. Thank you all for joining at this early or late time, and Zoltan, I'll share the video with you for uploading to our YouTube channel, right? And yeah, thanks everyone, and have a good day. And Tiago, keep up the good work. And please say a hearty thank you to Jose for the CityLearn UI work, and tell him that this is very much appreciated from the audience.